One of the coolest topics in grade 11 and 12 electric circuits is internal resistance. Let's go for it. You know that resistance in and of itself means the opposition to the flow of charge, and in an electric circuit it's the opposition to the flow of electrons. And you know that materials have resistance, and some materials have more resistance than others. Well, batteries are also made of certain materials, and these materials also have a resistance of their own. So ultimately, your internal resistance is the resistance of the actual battery. So if you have a circuit, you're going to need a source of energy, and that is going to be represented by a cell, which you are familiar with from grade 10 and grade 9 and grade 8, right? But now we're going to include the internal resistance. So we're going to show the cell connected to, in series, to a small resistor that will be represented by baby r and a dotted line. And then everything inside this dotted line will be considered to be the battery. And then the cell will be the EMF, which is the source of the energy of the circuit. Now, if I had a voltmeter connected across the terminals of a battery, or in other words, if I had a voltmeter connected in an open circuit, right, the reading of this voltmeter will be the EMF. And the EMF is the maximum work done per unit charge, which is the same as saying that it is the work done or the energy transferred to every charge before charges are actually flowing, or while no charge is flowing or no charge is moving in the circuit. That is your EMF. However, when my circuit is closed and when I actually have charges that are moving in the circuit now, and I have a voltmeter across the battery, this reading will be something called my terminal potential difference, and this is the potential difference in the circuit when charges are actually flowing. And so we have these two different values, and you know that these two values will be different. Your EMF will be much more than your terminal potential difference, and the difference between them is called the lost volts. This doesn't mean that volts are actually lost anywhere. Actually, what it means is that some energy has been used to actually move electrons through the cell. So some of the energy that is quote unquote lost, right, has been used to push the electrons out of the battery. And so we have that our EMF is actually the sum of our external potential difference plus the potential difference that is inside of the battery, or the lost volts. And from Ohm's law, we know that to get the external potential difference, we're going to multiply the current by the external resistance, and then we're going to add it by multiplying the current by the internal resistance. Okay, so to calculate the lost volts, you multiply the total current, or the current that's in the series circuit, by the internal resistance, and to get the external potential difference, or the potential difference in the external circuit, you're going to multiply the total current by the external resistance. And as usual, we can factor this out to simplify it. And so what we have is a grown-up version of Ohm's law. It's basically the same, even though it looks like an evolved Pokemon version of it, where your EMF would be the V, right? Your current is still the total current, and now your R has grown up a little, because instead of just having R for your total potential difference, you have to take into consideration the internal resistance now. So as you can see, it comes from Ohm's law that you are familiar with. It's basically the same, it's just a more advanced version of it, because the difference is, as you can see, that you are taking into account your internal resistance. So when you are doing calculations, these are the three main ways that you can use these equations, or the three different forms of these equations that you can use to calculate the EMF, the lost potential difference or the lost volts, the internal resistance or the external resistance. And then you need to use basic algebra to solve for the unknown based on what you are given and what is asked.